Let us directly go into the database design topic, which is the conceptual design using the entity relationship model. This basically gives you a pseudocode idea about how do you create a database. So if we directly look into the outlines of the chapter, we will start by looking into the overview of the database design. How does the database been designed? What kind of steps, what kind of requirements that you need to look through? And then we will look into an example. So in the example, we will use a company database by looking into the important informations. There are several important tables that we need to take care of those. So we need to understand the basic requirements of the database. By looking into those requirements, we will then walk into two important topics. One is the entity part, one is the relationship part. The entity is talking about how do you build up a table itself. The relationship indicating how do you link the tables together. So these are the outlines we will look in this chapter. Starting with the overview of the database design. The database design, there are two important factors that you need to understand before you are able to do anything, just like when you're writing a program. You need to know what is the input, what is the output. So there are the requirements of this program going to be. It's the same thing about the database design. So to create a database, there are two important factors you need to understand. The first one is the data requirements. What kind of data are you going to store? What's the main topic of the subject? And then you need to move into the functional requirements, indicating based on those data that you store, what kind of functionalities need to be provided. So those are the two important things you need to have in mind before you can create a database. Of course, that requires a lot of communication with the client and the database developer. Once all requirements has been collected and analyzed, the next step is to create what we call a conceptual schema for the database design. So this is what we call a conceptual design. The ER model is the conceptual design schema. Based on this concept, do not include the implementation details. So we just need to design the database without really writing the program. That's what I was talking about in the beginning of this class. We are basically creating the pseudocode for the database. However, to let you understand the pseudocode of the database, it requires some works. So they're usually easier to be understand and can be used to communicate with the users. Creating the requirements by using the language versus programming codes, they are two very different things, and therefore we have this intermediate step to communicate with our clients. Make sure this design fits their requirement without showing them the real code, because the coding is designed for computer scientists, not for everyone. And therefore, we need to start with what we call a conceptual design. In other words, we need to start with the ER diagram that we want to discuss in this chapter. The next step, once the conceptual design is done, the next step in the database design is actually implement the database using a language. So the language that we are going to learn in the DBMS terminology is basically the Oracle that we are going to use as our DBMS. By using the DBMS, we can transform conceptual design from high-level data model into implementation data model. So the high level over here is indicating it's not really the lower level of programming languages. Just like when we are writing the programs, Python is considered a higher level programming language, while C++, Java are considered lower level language, and of course assembly is considered the lowest level of language. High and low does not indicating the quality. It's just basically high level indicating it's more closer to human language, while low level is closer to computer language with 0 and 1s. So once we are able to map from the conceptual design into the data model. This is what we call a logical design or data model mapping. Once we have mapped that into the data model, then it is time to do the physical design, which means writing the program in Oracle. To summarize what we have seen for the past 2 slides, this is actually a very good picture or figure for you to understand what is the database design process. More importantly, it's basically slides tells you what are you going to learn throughout the whole semester. So starting with the mini world, that is going to be the topic that you need to work with to build up a database based upon. If this is a company database, your mini world is a company. So you need to know the things inside the company. If this is a university, then you need to know things about the university. If this is about a movie, you need to know things about a movie. And if this is a sport, just like NBA, then that is something you need to work on. Once you are understanding, have a focus of the mini world, the next thing that you need to do is you try to collect the requirements in both data requirements as well as function requirements. These are the 2 most important things that we need to look into. What kind of data that you need to collect, and based on the data that you collected, what kind of functionalities will you provide? So it's going to go into 2 routes. Based on the data requirement, we will need to start doing the conceptual design, which is build up a ER diagram over here. So when you be able to build up the ER diagram, this is what we call the conceptual design. At the same time, you also need to know what are those functions or requirements so that the 2 things can work together. You need to have the 2 things in your mind. And then based on your conceptual design, which is your ER model, then you need to do the logical mapping into a more closer to programming version of the ER diagram. That is what we call the relational schema diagram. Once you have that mapping done, create a relational schema diagram, it is then be able to write the program. So that is what's happening when you are able to create a pseudocode, go all the way to programming. And you can see that for the conceptual design as well as the functional analysis, they are DBMS independent, which means those design does not talking about the detail of the implementation. The detail of the implementation will happen after the logical design mapping, which means that when you create a relational schema diagram. Once you have built up this database, you will start working with the functional analysis, and then you can create application programming design. And basically, we will be able to do the queries or finding the informations from the database. Therefore, by looking into this big picture, you will understand the first part of the semester. The class will have 3 exams. So basically, the first exam is going to focus on the conceptual design, which is very clear to you that in this part, no coding is going to apply because they DBMS independent. You need to know what is database, and then you will be able to write the program. So for the first 1/3 of the semester, you actually will not use Oracle at all because you need to know what you are doing, what it is, what the database is. After we start doing the mapping, that is the time we will be able to create the relational schema diagram based on the ER diagram, and it is time for you to write a program to create the database. So once the database is done, the last 1/3 part is going to focus on the queries. And therefore, using the data that you have collected, the structure that you have created for your database, what kind of queries or what kind of functions can be created based on the database is going to be your last 1/3 of the semester. So you can see that the first 1/3 of the semester, there will be no coding. The second part, of the semester, we will start with the mapping. So the mapping itself has no coding. However, once you've done the mapping, then you will start writing the code to create a database. And the last 1/3 will be all coding basically, because you need to learn how to do the queries and how do you write the query codes in Oracle. So this gives you an overall, not only on the database design process, but also your semester-long study guide. Let us take a look at an example for the database application. So in this class, throughout the whole semester, we actually are going to use the company database as our example. So that we use one example throughout the whole semester makes it easier for you to understand the whole process. So the company database keeps track of the following things. They need to know the company's employee. They also need to track there are several departments of the company. There are projects that controlled by each department, as well as the dependents who are related to the employees. Suppose that after the requirement collection, so you can see that this part corresponding to the requirement collection and analysis. So the mini world is the company database. We know there are several things we need to keep track of, and we try to collect the requirements of this database, and therefore what we are looking at is this. Suppose we after the collection of the analysis phase, the database designer provides the following description. Remember, we have 4 different things that need to keep track of, including employee, department, project, and dependents. So each one of that need to have some description. So we need to create a database schema design based on the following things. Requirements of the company database. The company is organized into departments. So what are the information you need to keep track of the departments is given over here. Each department has a name, number, and an employee who manages the department, which means that is the manager of the department. We keep track of the start date of the department manager. A department may have several locations. So you can see that these are the human language descriptions about what the department is going to be. Let's take a look at the next one. Each department controls a number of projects. So basically, this description is about the project, the second table, projects. Each project has a unique name, unique number, and is located at a single location versus department can locate in multiple locations. This one, the project can only locate in one single location. Of course, in our ER diagram, we need to be able to keep track of those differences, and we will talk about how do we start looking into the entity and then move on to the relationship, which means that the relationship is connecting the department and projects. Employee is probably the most complicated one, because not only you need to store the basic information such as social security number, address, salary, sex, and birthday, they also have something more detailed information need to be keep track of. Each employee works for one department, but may work on several projects. So this is also something that very different from one thing to the other. So they can only work for exactly one department, and at the same time, they can work on several projects. So how does the ER diagram be able to keep track of all these differences? We keep track of number of hours per week that an employee currently works on each project. So for every project they works on, they need to keep track of how many hours they are working. We also need to keep track of the supervisor of each employee. And that's interesting because a supervisor is also an employee. So there is something we call recursive relationship over here. And these are the important things about the employee. Finally, dependents. Each dependent may have a number of dependents. This is an interesting thing. Previously, they said they have to work for one department and they can work on several projects. In this one, it's saying that the employee may have a number of dependents, indicating they can have many dependents. At the same time, they can have no dependents. So this dependence is something very special. For each dependent, we keep track of their name, sex, birthday, and relationship to the employee. And therefore, these are the requirements for the company database. To summarize this, company database has 4 different things that describing the company. So in this design, we don't really see what is a company. What we see is the company is consists of 4 different things. So as long as we describe those 4 tables and connects them together well, that 4 tables represents the company. And the 4 tables including the employee, department, projects, and their dependents. So in our next video, we want to talk about how do you describe each table. That is about the entity part, and then we will look into how do we link those tables together through the relationship topic.